In ancient and medieval alchemy, the properties of things were understood as separate entities, distinct from the existence of the bodies themselves, and, therefore, at least in principle, transferable from one body to another. For example, sulfur, understood not as the ordinary chemical element but as an underlying principle, was the expression of the combustibility of bodies. Salt, the expression of their solubility, while mercury embodied metallicity. By physically separating and combining these entities, one metal could be transformed into another. As late as the 13th century, Albertus Magnus discussed the possibility of transmuting metals in this way in his treatise De Mineralibus. But roughly 3 centuries later, scientists started to approach nature in a fundamentally different way. Galileo, for instance, no longer explained the fall of a body in Aristotelian terms by appealing to an inner quality such as heaviness, but rather as a universal law of motion in space that can be expressed as a mathematical function. This transition from thinking in substance to thinking in functions was regarded by the philosopher Ernst Cassirer as the conceptual revolution separating pre-modern from modern science. The mind orders the individual things it encounters in the world through abstraction. By means of comparison, similarities and differences can be identified. The common feature shared by a series of objects can then be brought together under a general concept. What parrots, crows, and so on have in common makes them birds. Birds, mammals, and so forth are in turn part of the higher general concept animal. In this way, a pyramid of concepts arises. According to Plato, the higher concept forms the ontological foundation of the lower ones. Yet not only this latter idea was contested, the entire classical theory of concept formation involves a number of problems. First, the higher the concept, the poorer it becomes in content, since the number of distinguishing characteristics continually decreases. The highest concept would therefore be the most abstract and, at the same time, the emptiest and least meaningful concept. In other words, as the degree of generality increases, the extension of a concept grows while its intension diminishes. Second, this form of concept formation rests on a single principle of selection, namely similarity. It remains unclear why similarity should be privileged as the guiding criterion rather than other possible forms of relation between objects. Third, the question arises by what criterion one decides which properties are essential and which are accidental. The characteristics gathered together in a concept are supposed to express the essential determinations of things, yet it remains problematic how abstraction can be guaranteed to capture what is truly essential. Hegel, for example, points out that human beings can be distinguished from animals by their earlobes, but this is obviously not the essential characteristic of human beings. Finally, the question arises of how the particular can participate in the universal at all. If the universal is obtained merely through abstraction from many individual cases, it remains unclear in what sense it is anything more than a retrospective summary of those cases. Aristotelian metaphysics answers the last two questions through the doctrine of the species type. The species type is not merely a collection of common characteristics, but the immanent essential form of an individual thing, structuring its development and directing it toward a particular end. In this sense, an acorn contains an inner determination that guides its development into an oak tree. This self-realizing species type constitutes the essence of a thing independently of its changing accidental properties. From Aristotle follows that the complete system of scientific definitions would also be a complete expression of the substantial forces which control reality. Within this framework, all properties such as quantity, quality, place, or temporal determination appear as determinations of an underlying substance which counts as reality in the proper sense. Although Aristotle describes and systematizes relations between things, substance remains primary. Relations are secondary and significant only insofar as they are tied to substances. In this sense, there is no genuine division between nominalism and realism, since both positions remain within a substantialist ontological framework. The philosophy of nature and alchemy of the Middle Ages radicalizes this basic structure by treating qualitative properties themselves as independent principles. As I've already mentioned before, qualities such as combustibility, solubility, or metallicity were treated not merely as properties of things, but as real components contained within them. The characteristics shared by a class of objects were therefore understood both as the basis of a concept and as physical ingredients that could, in principle, be separated from one thing and transferred to another. If one removes from tin its creaking, its fusibility, and its softness, it can gradually be transformed into silver. This logic can still be found in Bacon's physics. Only slowly and step by step does science free itself from this worldview over the centuries. A major shift appears in Newton, who no longer treats gravitation as a kind of substance, but as a force relation that can be represented as a functional law. In the series IA, IB, IC, and so on, I is the common element that seems to determine the series. Yet there is a second possibility of determination. A series can also be held together by something that is not contained as a common component in its members, but rather by the rule governing their progression, that is, by a function f that relates the members to one another, such as f of x equals x plus 1. Here, a fundamental difference from classical concept formation becomes visible. The classical ontological concept can proceed only through abstraction from the particular to the universal, but it cannot return from the universal to the particulars. Remove from bird to animal, but there is no way that we can deduce the existence of birds from the definition of animal. A function, by contrast, contains not merely an abstract commonality, but a rule for generating all of the individual members. For that reason, it can reproduce the entire series. Cassirer argues that this form of concept formation is not restricted to mathematics. Empirical concepts can also be functionally structured. The modern scientific concept of metal, for example, does not abstract from all variable properties such as density or weight. Rather, it captures the lawfulness according to which certain variations are possible within a unified class of cases. We then do not move directly from a series A alpha beta to a common constituent A. Instead, we understand the variations of the determinations alpha and beta as systematically variable quantities x and y. We can therefore designate the entire system as AXY. We may abstract from the specific density of copper, silver, and so on, but we still keep in mind that any metal has to have a specific density, weight, color, and so forth. The concept of metal no longer signifies a mere intersection of common properties, but rather the system of relations through which the individual determinations are connected. In this way, relation itself becomes the constitutive moment of the concept. It is no longer something externally added to things, but the principle through which the unity of multiplicity is determined in the first place. The periodic table provides a good example insofar as individual elements are not merely listed there, but are determined, and in some cases even predicted, on the basis of their position in a system. Something thus enters the picture that does not occur in the series as an isolable thing. A function is not a component of the series, but its rule of generation. The classical concept, by contrast, appears as something that, in a sense, occurs as a property within things themselves. A relation, however, cannot appear as an object within the series, but remains, so to speak, in the background. This background makes explicit that whenever we seek to establish the similarity of things, a point of view must already be given that is itself not a thing. When I perceive different things, for example a cloud, a bird, a car, and so on, I do not immediately attempt to form a concept encompassing all of them. Before a concept is formed, the things have usually already been arranged and ordered in a certain way. Abstraction occurs only afterwards. Cassirer sees the progress of the sciences as bound up with a transition from thinking in substances to thinking in functions. To demonstrate this, he discusses numerous examples from the history of mathematics and natural science. This change becomes especially clear for him in modern number theory, particularly in the work of Richard Dedekind. Dedekind still begins with things and their mental images, but mathematical concepts are no longer formed through the isolation of common substantial features. Rather, they are formed through the determination of relations. For Dedekind, the essence of numbers lies in their position within a structure. In a numerical series, one number follows another not physically or temporally, as thunder follows lightning, but through a purely conceptual and systematic dependence. Whereas older views often began from individual numbers as given units that were subsequently related to one another in equations, attention now shifts to the structure of these relations itself. A number derives its identity through the relation between the preceding and the succeeding. We can see something similar in David Hilbert's Foundations of Geometry. Hilbert departed from Euclid's approach by leaving fundamental concepts such as points and lines undefined and specifying only the relationships among them through axioms. For example, he defines concepts such as congruent and intersecting, which Euclid did not define. For Cassirer, the self-understanding of mathematics changes from a science of magnitude or quantity into a science of form and series. He sees evidence that mathematics concerns qualities as much as quantities in Leibniz's combinatorics, which is concerned less with the number of possible connections than with the possible forms of connections themselves. Individual elements are no longer grasped in terms of what they are in themselves. They are merely instances of valid forms of order and connection. The elements derive their being solely through participation in these forms. Modern mathematics is therefore not primarily concerned with comparing, dividing, or combining given magnitudes. Its central concern is the investigation of the structures and functions through which mathematical objects are generated. The natural scientist does not simply abstract the law of nature from raw reality. Rather, in scientific experiments, an idealized and simplified case is considered. For example, in Galileo's works, the concept of uniform acceleration is first defined, although such a case is never fully given in reality. Uniform acceleration is a functional concept that assigns spatial values to temporal values according to a fixed rule. Starting from this ideal concept, one subsequently approaches actual processes of reality by taking further factors into account, such as air resistance or the variation of gravity with distance from the Earth's center. Reality is therefore not treated as a set of given substances that must be extracted through abstraction. Rather, reality is something that is grasped through a system of functional determinations that can be gradually extended and refined. Since mathematics remains within the ideal, a mathematical function can fully determine a structure, but reality is more complex than any model, or, in Kantian terms, experience is in principle never complete. There are always further factors that remain unaccounted for. The progress of physics, therefore, usually does not consist in the complete rejection of earlier knowledge, but in its supplementation by further determinations that explain new observations. The substance concept separates the essential from the accidental and leaves the latter behind. The traditional pyramid of concepts moves ever further away from concrete reality. The function concept, by contrast, keeps open the possibility of including further determinations in the explanation that approach reality step by step. Factors are initially excluded because they are still unknown, cannot yet be calculated, or may be neglected for the purpose of a given question. Nevertheless, there remains room to include them later in the analysis. Galileo's law of free fall does not have to be replaced by a better theory in order to describe the motion of a body in air resistance. Instead, it is supplemented by additional determinations. A single natural event is determined by its position within various functional contexts. These functions, such as air resistance, gravitation, and so on, can be combined without any of them losing their content. In this way, the classical metaphysical problem of how the particular can participate in the universal loses its mysterious character. The universal is no longer a substantial thing that must be present in the particular, but rather a rule or function through which individual phenomena are determined. The classical problem is transformed into the question of how different lawful contexts can be mediated with one another in order to explain a concrete event. Whereas ancient philosophy focused on a whole to be divided, or on parts that compose a whole, the emphasis now falls on the formation of series. For Cassirer, the function concept is not an invention of philosophy that is later adopted by the sciences. Rather, it organically emerges from the internal development of the sciences themselves as a response to concrete scientific problems. So if, for Cassirer, the transition from the substance concept to the function concept is tied to the progress of the sciences, what then is the situation in philosophy? Cassirer believed that philosophy should undergo a similar transformation. As a committed Kantian, he saw the most promising path in a Neo-Kantian system, which he later developed himself under the title Philosophy of Symbolic Forms. But can we observe now, more than a century after Cassirer published his book on substance and function, a general trend in Western philosophy from substance to relation? Probably not across the whole philosophical tradition. Yet many influential currents of contemporary thought are characterized by a strong anti-essentialism and by a tendency to regard functions and relations, or processes and events, as more fundamental than self-subsistent substances.